Hello and welcome to the August 2021 edition of No Diagnostic Required, a monthly look at what's happening in the C++ community. With me, Phil Nash, and my co-host, Anastasia Kezakova.
Yeah.
So how are you doing this month?
Doing good. Actually, no, it's quite late here in St. Petersburg, and I'm just from the London theater. While I'm still in St. Petersburg, so no travel involved. So even though no diagnostic required, but I will try to explain myself. Like in this pandemic time, this is actually a great thing, which you can go to the cinema and watch the drama recorded in some theater, for example, in London, which I just did. So I was happily looking at Cyrano de Bergerac, and it was great. So I feel like I'm just from London, so a little bit closer to where you are now, Phil. So yeah, how are you this month?
Well, I actually am, very close to London, but that's just because that's where I happen to live. No, I'm good. Bit of a shame that the summer seems to be ending prematurely here in the UK, but well, there'll be another year, I'm sure.
Yeah, hopefully.
Now, before we get into it, I just wanted to make a little correction to last month's episode when we talked about stud execution. I said, and this was just on the recorded show, not in the written material on C++ Annotated. I actually said that it was like a stripped back, lean and mean, minimum viable executors. But I actually realised afterwards that wasn't really the case. In fact, it's quite misleading. So when I did write it up in C++ Annotated, I actually just pointed out that it was actually a larger paper than executors with obviously a different focus. So I just wanted to correct that and use that as an example of how what we're doing here, it's just our opinions, our interpretations, and sometimes even a hot take. So do bear that in mind when you listen to what we have to say. With that in mind, let's get into the material we've got for today. So do you want to take us through this no unique address article?
Yeah, actually, it's both about the no unique address and empty base class optimization on its own. So the article talks about this new C++20 attribute in the context of the empty base class optimization. So if you don't know, this optimization allows saving the memory on empty structs via inheritance. So, and the idea is that if you know that your class is empty, then you can inherit from that class, and the compiler won't enlarge the derived class. So, and now there is this new attribute in C++20 called no unique address to help you with actually the same thing, just in the language. So a new attribute indicates that a unique address is not required for a non-static data member of a class. So actually it doesn't. It just does the same job. And the compiler may optimize the space, actually the memory. And interestingly, in the article itself, so you can find a few useful examples how this could be used in some practical examples. But it's interesting discussion that actually there in the end, which kind of caught my eye, is about the ABI, which might be affected as the result of the usage of this attribute. And because this attribute actually changes the layout. And this is very interesting. In fact, I mean, the community right now is quite actively discussing all these ABI questions. And, I think we're kind of becoming very sensible in terms of the ABI questions. I don't know how about you, but I definitely feel the vibes in the community. So it was interesting actually to capture this idea. The situation was discussed in the GitHub issue for Microsoft STL. It was noticed there that Clang listed this attribute as supported in version 9. But it was not the case when the Clang was targeting Windows because MSVC didn't support the attribute. And Stephen LaValle actually started that the attribute is now supported in MSVC, but it's too late to request Clang support to take advantage of it because of the API lockdown for C++20. So that was actually an interesting consequence. We have the feature implemented, but we actually can't rely on it because of all these ABI questions. So that was actually what caught my eye in the article. But overall, it's a nice example of of the attribute can be useful. So do check out if you just have no idea or haven't heard a lot about it. So it's kind of very useful. So yeah, that's I guess all I wanted to say about the point. So any thoughts here from you, Phil?
Yeah, the ABI aspect to it is a bit unfortunate, as it always is when it comes to ABI issues. Just another example of why we really need to do something about it. Because we can't have it both ways at the moment. But just the feature itself, a no unique address, nice simple thing that addresses a need that we've been able to work around before by abusing existing language features at the cost of making the code very obtuse and just harder to read and reason about and probably compile. Now we have a feature that does exactly what we want, which is just to say, well, this particular member doesn't have a unique address because it's not needed and may very well be empty. So I think that I really like these features because we do tend to abuse the language a lot because we want to make it do things that it doesn't do. And that's what standardization is for. So when we can rely on the features when ABI is not getting in the way, that's a really good thing.
Yeah, that's true. That's true. Okay, let's maybe move forward. And talk about this nice article by author. So I think I can maybe even stop on the article title here, and say no more because it speaks for itself. So don't explicitly instantiate to templates. That's the major outcome of the article, actually. But if we get into more details, so it started with just a similar rule like not to forward declare standard library types, but then it gets the example that let you help understand the further rules. So, and the major idea of the whole case is that implicit instantiation is lazy and can only instantiate the needed parts. So it will skip the parts it doesn't need. So and there is some nice example of the struct with two functions f and j is not legal, but that's totally fine until you don't call it. So and you only call the f function, but the explicit instantiation actually does so for every member. So the problem is that stud templates actually rely on this laziness. So if you try to explicitly instantiate them, you might get into trouble. There was a very interesting observation again in the end. I know they're all interesting observations are actually in the end, I know that, but there is some rule recommended by the standard itself regarding the explicit instantiation, which is contradictory. So, and it says that the program may explicitly instantiate a class template defined in the standard library only if the declaration depends on the name of at least one program-defined type or the instantiation meets the standard library requirements for the original template. But the author actually says that you'd better not follow this standard advice and stay a little bit away because of the reasons mentioned earlier. So, and yeah, for the Clang users, there is kind of workaround. There is this compiler-specific attribute, something like exclude from explicit instantiation, which you can actually use to avoid these kind of problems, but it's only Clang, so there is nothing in GCC like that. So yeah, and that's an interesting article, I would say, an interesting observation there. So do check the examples if you would like to get into more details. But yeah, everything is in the title. So just learn that do not explicitly instantiate to templates. That's it. So you can stop here.
Yeah, Arthur's articles, as always, are informative, insightful, and well written. This is no exception.
That's true.
Yeah, but the one thing I felt was perhaps missing was explanation of why you might want to explicitly instantiate a std template, or any template, in fact. And I think part of the problem is there's really two reasons, and they are almost orthogonal to each other, although there is some crossover. One is when you do actually want it to instantiate all of its members, all of its dependent members. So exactly the thing that causes the problem here. The other is perhaps for compile time performance purposes. If you have an expensive type you may want to instantiate it, and especially if you can combine that with what's now being standardized as extern template, but for many years was available as an extension, at least with the Microsoft compiler. You can actually then instantiate it in a CPP file and extern it in a header file, and you won't pay the cost of instantiation every time you use it then. I've actually used that trick before. Now, I'm not sure that you would really want to do that with a stud type, so I'm not really sure why people want to do that with stud templates anyway, but it can actually be useful in your own code. But just felt that was sort of missing from the discussion a bit.
Yeah, I guess Arthur was actually noticing that it's not a very, popular case anyway. So it's not the thing you do regularly, but still you'd better be aware of why it's bad than not just using it silently,
Yeah. Whereas forward declaring standard types can actually be quite tempting. Again, mostly for performance purposes, compile time performance purposes. And I believe the doc test framework actually uses that trick fairly extensively to get its compile times down. Obviously, at the cost of invoking undefined behavior, but if you do that on an implementation by implementation basis, you can get away with it. But in general, follow Arthur's advice and just don't do it.
Yeah, that's true.
Okay, what about modules then? Got a bit of news on modules this month.
Yeah, I would say that like modulus related topics are hot these days, so they're very, very popular. But I would say there is a lack of good practical tutorials. So the people are more still discussing how the feature is structured in the language, what we're still struggling for in terms of the compiler support or project model support. So surprisingly, in August, I noticed 2 blog posts with quite a practical approach to the thing. So the first one is this one about the modulus with surprisingly GCC 11. So I was first a little bit surprised because to me the modulus is like the thing which is supported in MSVC plus MSBuild. But like with GCC 11, what do I use as a project model? And the answer was actually very simple. No project model at all is involved in the blog post, so don't worry about that. So it's just a compiler thing. But it's related to GCC 11 mostly because the author actually discusses how the things are different from the Microsoft implementation. There are a few places like that. So in general, the article discusses the C++20 modulus and focusing on 2 different approaches of organizing the model structure, like the single file modulus or like separate interface and implementation files. And so there are just quite basic examples compiled by GCC 11, so you can follow them if you would like to start with the model. And as I mentioned, there are a few differences discussed in the article between the GCC 11 and Microsoft implementation, so you can check them. For example, there is this discussion about no agreement on file name extensions, at least no common agreement. So I would say there is a little bit of a mess there with the standard extensions, but you can still deal with that. And also some details like private fragments, which are not supported by GCC 11, at least for now. So anyway, the blog post is a good start if you would like, just to write some model and play with it. And GCC 11 now supports the model, so everything is fine, except for the fact that the blog post doesn't really help with the modularization of the current code base. So if I have already a code base which I would like to convert to modulus, this is like kind of basic thing, but it's all anyway good to read through it. And so there's such questions covered like how to build a simple model, how to export a function, a namespace and type, import things and build everything together. So yeah, everything is just discussed there. So you can learn this kind of C++20 model as basics and write a new model. But if you would like to modularize an existing code base, I would recommend you checking the next blog post from Microsoft. And it's about moving a project to C++ named modulus. And it's exactly what I said. So it takes the project without modulus. So the existing code base, it's actually located on a GitHub. So you can play with this application, play with the example. and it shows how you can introduce modulus into that. So it's kind of a little bit straightforward, especially in the beginning, because they just mimic the header structures. So they just take this inheritance tree with the headers located in the project, and then just convert all the headers into the corresponding modulus with very little changes, I would say, just required to make the modulus correct. So the hierarchy is actually preserved and everything just converted to modulus following this hierarchy, but it's kind of nicely thought in advance, so it actually allows that. I'm not sure every project actually follows this, nicely structured way of, presenting the libraries, but if you a lucky one, if you have, then the conversion will be quite easy. The interesting question discussed later is how you convert to modulus the third-party code, and there is some non-trivial task which you might have which you might require at this point, like they discuss how the static constants have to be wrapped with functions to import later, because the internal linkage entity can't be exported. So the things like that is discussed there. So that you have to actually update the code you have to introduce modulus. And surprisingly, there is, I would say, a fantastic completion time improvement stated in the article. At least for their project, there is like, for one of the file, they have like 3.5 something seconds without modulus and 0.15 with modulus. So it's like more than 20 times improvement. So it's really great. I don't think like we will be all happy like that with just, introducing modulus, but who knows, maybe like if you indeed have this very straightforward hierarchy of your headers, and you just convert them mimicking the structure, then it's indeed will be that very straightforward and easy to convert into modulus. And yeah, so this is the blog post which can help if you would like to introduce modulus into your existing code base. But you definitely first need, to clean a little bit, make it more structured. Maybe think about the how separate the parts are, so that they're, not just mixed all together. And then, yeah, you can use this tutorial. It's actually the tutorial by Microsoft Teams, so it definitely relies on Microsoft implementation. Interestingly, the project on GitHub is in CMake, but since CMake still doesn't have support for C++20 modulus, the first step they do is actually generate the MS build from the CMake and then proceed. So yeah, that was a fun part, I would say. Yeah, and I think that's what I wanted to say about it. What do you think about these guidelines, about these two tutorials, Phil?
Well, as we said before, modules are going to solve all of our problems. We just need to get there. Grass is definitely greener on the module side, but the problem is always, how do we get from where we are now to that promised land of modules, especially in these early days without the tooling support being ubiquitous or even well known. So these practical articles that sort of take existing code bases right now with the tools that we have right now and see what we can actually do, which in some cases might not be much, but if you do have some tooling support, like the Microsoft project model, then there are things we can do, and it's nice to see that actually laid out in a real world way. In terms of the build time improvements, I can actually believe those figures that are quoted there. I'm not sure if I mentioned this before, so I know we have talked about modules performance before, but previous project I worked on when we were using Visual Studio, it's quite a large code base, split across about 40 DLL projects, I think. And what we found was if we compiled a pre-compiled header right at the start and then shared that between the projects, we got our build times down from over an hour to under 10 minutes. The problem was that wasn't actually a supported way of doing things, and we ran into problems with the debugger, and we ended up having to undo it all. But it showed the potential for what can happen if you can share in a granular enough way those pre-compiled symbols. And it's never been guaranteed that we'd actually see that with modules, but always been hopeful. So it's nice to see some figures actually bearing out similar sorts of improvements there. So yeah, I'm hopeful that at least in some cases that will really be the case.
Yeah.
Okay, let's move on to the standards news section. And the first one I want to look at this time, it's an unusual proposal, and it's unusual in that it's removing things, and not just one thing, but many actually. But also unusual in that when you first read it, you think, why on earth would we want to do that? It seems to be going backwards. And this was actually picked up on CPP Cast a couple of weeks ago, and they had the same reaction. And you can read the title, and you can even read into it a bit, and still have that reaction. But I think if you dig a bit deeper, you do actually start to see where this is all coming from. And with some prompting by a colleague of mine, Tomasz Kaminski, now at Sonosource, encouraged me to actually look into this properly. I've now come round to, I think, agreeing with Ville, the author of this paper, and the others that were on the thread, on the committee mailer that led to this. So it's worth just spending a little bit of time picking this apart, because I think it's quite important, actually. So, first of all, what are we talking about here? Hopefully most people are familiar with nodiscard, but in case not, it's an attribute introduced in C++ 17 that you can mark up return types on functions with, either at the function level or on the type itself. So you can do it either way. In fact, it was extended in C++ 20 to include an extra string that explains why these types shouldn't be discarded. And they're for those cases where you, as the owner of this function or type, really think that if you don't actually use the return value, you're probably doing something wrong. It's almost certainly going to be a bug. Or it may just be not a very good way of dealing with things. For example, if the return type is an error code, probably you should be looking at that, because otherwise you may run into problems and not know what's going wrong. If it's what we might call a pure function, so all it does is take its inputs, do some sort of computation and return a result based on that. If you're not actually using that result, then why are you calling the function? It probably indicates that you've misunderstood what the function does, or again, you've just introduced a bug somewhere. So it almost always indicates a bug, and when you do get that bug, they're often very hard to track down. So this seems like a really great feature. You can now put in something that will say, no, don't actually discard this return value, and if you do, it's probably a bug, and compilers can do something with that. But they're not required to. In fact, this is one of those cases where there is no diagnostic required. We like that phrase here. But this starts to get at the one of the issues with this. So what then happened is, so it's introduced in C++ 17, but more recently there's been a push to start to use this throughout the standard library. And so there have been a number of proposals that have put it into the standard library already. Some of these have already been adopted, some of them are still going through the process. They all seem like a great idea. We talked about one of them back in May, I think. And we said, yeah, great, that's what we want. But remember, compilers are not required to give a diagnostic. So this may actually do nothing, but they also are not required to have it specified in the standard in order to put it in. In other words, a standard library author can put no discard wherever they want. That's fine as well. That's completely conforming. So you don't actually need it to be specified. And you don't even need to put no discard in order for a compiler or some other tool like a linter to issue a diagnostic. So really weakening the case for why we actually need this to be specified in the standard. In fact, the paper actually says that they specify nothing, so it's questionable to put them into a specification. But that's quite a nice turn of phrase. Okay, at this point, as I was reading, I was thinking, well, I can sort of see where that's coming from, but surely still it's better to have it in the standard so that we get more of them. But then we go on. First of all, actually anyone potentially can submit patches or pull requests to any of the standard libraries to add these directly into the code without having to go through the standardization process. And that process of standardization is quite expensive. We spend a lot of committee time going through the paper, going through wording, adding it to the document itself. And then there's the chance of false positives if we put it in the wrong place. And some of them seem obvious, but some of them not so much. Plus, they introduce extra verbosity in the code. There's a cost to this, and it seems very little benefit. We also like to standardize existing practice, so surely the best way to do it, given that we can just put it into the standard libraries, is to put it in the standard libraries and then decide whether we want to put it into the standard itself later. And then we get the best of both worlds. Okay, that almost seals the deal, but for me, the thing that really sealed it was, is this even the best approach? There are other approaches, such as specifying that whole classes of function, if you like all the empty functions, for example, which is one of the classic cases where it could be confusing, it should be implicitly no discard. We can say that in the standard. That's something you can put into the standard. And that means you don't have to clutter up all of the code with no discard. It just automatically is effectively no discard. And there may be even other things that we can do, even at some future point, making something like no discard the default and having to opt out with something like discardable. And that sounds like the sort of thing that, no, we'd never get that. But bear in mind, you can already get that behavior now in most compilers with a flag. I think the unused flag, you'll get warnings if you ignore any return value. So maybe introducing the opposite attribute might be something we would look at in the future. That's being talked about at the moment. There's no serious proposals that I know of at the moment to do so. But that seems like a more promising approach. So actually, maybe we don't want to spend too much time going down this dead-end path. Maybe we should concentrate the effort on a more general, more useful feature instead. So read it yourself if you're still not convinced, and make sure you do actually, take on board each point, because I find it quite insightful, the whole process of getting from that's an obvious good thing to that's obviously not something we want to do, which so often happens when it comes to C++ standards. So, did you have any thoughts on that, Anastasia?
Yeah, I'm just, thinking about the fact that there is a standard library specification and there are standard libraries, which we have more than one.
Yeah.
And the situation which I don't want to find myself in is then when everything is just different. I mean, the specification and the implementation, that's the only situation I want to avoid. The others, probably it's fine, but I'm just thinking about how much work still have to be done if we follow, for example, this path described here. So I don't know, maybe it's the people who are saying that it's too much work are right. I don't know. The goal seems fine, but again, maybe we can spend, trying to optimize the time of the committee, and maybe they can spend time on something different. But I don't know. I'm not that good expert here. I'm just thinking about that. What I definitely don't want to lose is the fact that I have the standard library specification and the actual standard libraries. I don't want them to be different. I don't want the people doing different things in the specification in the libraries themselves, because this is painful, not just for the tools we're working at, but for all the developers.
So you used the word behavior a moment ago. This attribute doesn't change behavior, not of the code. It might change the behavior of the compiler.
You're right. Yeah, but
actually that's already different. That was one of the first things I said is they're not required to do any of these things. So putting it into the standard doesn't actually change anything in practice. They're already putting these into the implementations. They don't need the specification to say that they should, and then have the option to ignore it. So
yeah, maybe you're
right.
It really
doesn't
here.
change anything.
Yeah, maybe you're right here, but like, when you have a change which doesn't really change anything, then you have a question of should we really spend the time on it. But reasonable enough at least to discuss that.
Yeah. And this certainly doesn't change the usefulness of using nodiscard in your own code. This is purely about whether it should be a specification exercise for the standard library. So yeah, it was an interesting one, I thought. Okay. Now, we spent quite a bit of time on that. I'm not going to spend quite so much time on these two. In fact, I think there was a third one as well, all to do with std format and encodings, locale handling, things to do with localization, basically, and Unicode in many cases. There were a few of these that went in. And the reason I wanted to highlight them was partly because we mentioned std format a lot, so it's a nice one to rally behind. But mistakes have been made, things have been missed before, which is fine because this is actually complex stuff, and that's really the point. Anything to do with locales, encodings, Unicode, it's not only hard to get right, it's hard to remember when it's you even need to consider it. And I think, for example, in the chrono case, there were two proposals being standardized at the same time that thought they had got the intersection right and something got missed, and that's really hard. And it's great that this is now being fixed, it's been spotted, and there are people hard at work. I mean, Victor, the author of std format, he's been involved, Peter Brett on there from SG16, and others from SG16. They've really been hard at work trying to fix the big mess that is text encoding in C++. That's a massive job that we're not really going to see the full fruits of for probably not in 23, maybe in 26. Hopefully we'll get something more. But all these little paper cuts along the way, they're also trying to address. And it's largely sort of unsung work because there are no big features yet. But I just thought it was worth calling out the work that's going on there to just trying to deal with this big mess. So, any thoughts on that?
Like not that many actually. I'm just thinking about that. C++ 23 is indeed a release fixing the issues, and that's probably how it should be after the big C++ 20. So yeah, it's totally fine just to get all these things for chrono and others actually to be actually accepted to C++ 23. So yeah, that's just like a normal process, I think. I don't think we need to change all the things with every release. So these fixes are nice, probably.
No, that's right. But I think one of these, I forget which one now, didn't make a note of it, but I seem to remember one of them did actually involve a slight ABI break. So
yeah, the ABI vibes, as I said.
It was one we could roll with. That's the thing. There's not just one type of ABI break, and some are bigger than others. But yeah, gets in the way all the time.
Yeah, probably we had more before, but we're now just more accurate with that.
we're more aware of it. Yeah.
Yeah.
Okay. Last month we talked about P2388R0, which at the time was called abort-only contract support, I believe. So R1 is out. It's got a different name now. Minimum contract support, either ignore or check and abort. So taking a cue, I think, from Arthur Dwyer's blog titles, trying to put the whole message in the title. And in fact, that's the theme of this update. It doesn't really substantially change the content. It's still saying the same thing. It's just a big reorganization of the proposal, taken on board lots of feedback that they've had, and substantially expanded. It's had wording now. So the reason I brought this up, even though there's not really any changes to talk about of substance, is just to show that, yes, this is being worked on, it's being treated seriously, there's a lot of interest in it, and it looks like it may well be on track for C++ 23. So we may actually get minimal contract support in C++ 23, and I think that's a big thing. So worth cheering us on as it goes through, I think. Anything else to say on that?
Let's get at least something.
Yeah.
If we can't get everything, let's get at least something. That's a good approach. I totally agree. So I think we need contracts, and we need at least start standardizing the things we want there. So even though we can't get everything at once, and maybe there was too ambitious goal, to get everything at once, maybe this way, like getting it to it step by step, will like at least improve, and will indeed get something.
Yeah, and certainly the idea is that once this is in, then we will start looking at those bigger, more controversial aspects to it, like continuation, undefined behavior, and so on. We will have those conversations, but they're not going to hold this up at this point. That's the main thing.
Yeah, that's true.
Okay, well, let's turn the page to look at tools now. So this is mostly back over to you again, Anastasia. Can you talk us through Valgrind?
Let's talk about the tools. I actually picked that up, and some people might think that, that's too old, but it's actually not. I think like Valgrind, not just the mem check, but the whole tool is just great. I think like I was digging once in how it all written, and it's a nicely, I would say a nice piece of code actually. So with a very nice architecture and how it all works. And as the article mentions, so it still can like knock down sanitizers in a few use cases. And the most obvious one is when you trying to catch issues in the library with the source code, which is not accessible to you, so you don't have it, and you can't actually recompile with sanitized flags. You maybe want to, but that's not the option you have. So you definitely, the only thing you can do is run with the Valgrind, and so because you don't need a recompilation in case of the Valgrind. So, and it also can like help with some specific cases, like it can search for memory errors with address, which some address issues, and at the same time detect uninitialized memory. And that's not the 2 runs, but that's just, you do that with one Valgrind run, which is also great. But the biggest benefit is probably that it's a very interesting piece of code, and it's actually a core. I mean, like, it's not the tool which is capable of think 1, 2, 3. It's actually a core part and several how they are called tool plugins, which are working on top of that core. Like memcheck, for example, is just one. There are also like others, maybe less known than the Valgrind memcheck. It's probably the most popular one, but there are more, and you can actually implement your own. So you just get this core part, which just loads the software and disassembles it, and then you can write a tool plugin or use one tool plugin existing there, which adds the instrumentation and assembles everything back. So it's an interesting article which just dives into how the Valgrind works. Actually like the Craft CPP blog for these nice pictures how the things are working. So you can look at the Valgrind architecture. It's actually indeed a very nice tool, so you can see how it all works for these things. There are definitely some known limitations for the Valgrind discussed in the article, so you can't escape from them. For example, like the execution times and the memory usage, which are significantly higher compared to the sanitizer's case. Everyone knows that, and like you can just skip this fact. But if you don't have any other choice, like with this library with an accessible code, so that's fine. That's what you pay for getting the result. So the article is just quite a basic overview of what can be done with the Valgrind, and a few cases where it actually is more helpful than the sanitizers. So even if you're, a sanitizer fan, just do and check out the article just to see these nice cases and just how it works. So I was actually using Valgrind a lot in the past while I was developing, and I found it quite useful. And I really like how it, introduces all the results to me and how I can check for these results. So yeah, it's a nice tool, and I quite like the fact that it's a core plus tool plugins. So thinking maybe about adding some functionality into it by adding this some kind of an extra plugin would be interesting, at least to inspect this. So any thoughts on that, Phil?
Yeah, it's definitely a case of know your tools, know what they're useful for, when to reach for the right one. And included in that is knowing what they're called. You mentioned that Valgrind is quite an old tool now, but how many of us don't actually know how to pronounce the name? I know when I first did a video for it when I was at JetBrains on integration with CLion, actually I had to go and look up how to pronounce it just to make sure that I said it right. So it is Valgrind and not Valgrind, as many people do say. So you heard it here first.
Yeah, I actually heard, I guess, both options from the people, but me, myself, I was mostly calling it Valgrind all the time, and I was very much surprised when I've heard Valgrind. I was thinking, like, maybe I'm doing that wrong. But no, I used to the Valgrind names, so, and hopefully I'm correct here.
Yeah. Okay, so more tools. We got the Intel compilers adopting LLVM.
Yeah, I would say quite a big news announced by Intel that they moved their compiler to the LLVM infrastructure. So I would say like there are three major compilers where all the time we're talking about, like Clang, GCC, and MSVC. But Intel is also there, so it may be not in the top three most popular, but it definitely the compiler which the people tend to choose when they want the optimal performance for Intel architecture, because it's optimized exactly for Intel architecture. So it makes sense to use this compiler in this case. And moving to LLVM infrastructure is definitely a trend. Tell us. We know. And it gives you the obvious benefits, like there is a huge community behind the LLVM moving it forward. And so you actually, and it's open source, and you actually get the C++ language standards nearly for free. It's actually not that free. But anyway, so if you migrate, you get this kind of features implemented for you by the whole community. So you're not there just alone with your battle. There is this, when I said that it's not really for free, the thing is that, and I think that's what Intel plans to do, is that they're gonna maintain their own branch, just the same way as we do for like CLion, where we do maintain our own LLVM branch for ClangD. And so they gonna merge the most general things back, but they not gonna merge some, Intel architecture specific things back. And that means that they will have these tough times when they need to, get the new updates from the LLVM. And I know what I'm talking about, so we do that on a regular basis. And so it's sometimes quite painful. So it's not really for free. So you get many things there just because you update the LLVM version you're currently using. But it's not really free, so you still spend time on that. But anyway, that means that Intel LLVM is now like capable of the things which are available in LLVM. So in terms of the C++ language standard supports, it's should be quite nice. And yeah, it still will be optimized for Intel architecture, and that's exactly the thing they're not gonna push back. So, and it seems that Intel LLVM will still be a better choice for Intel architecture than the general LLVM. And they have a few benchmarks in the article. I would say even more than few. So they have actually quite a lot, some parts discussing these benchmarks and the performance. And they also have, they actually recommend their users to migrate to a new compiler as soon as they're ready to, because they will move the old one to a legacy mode quite soon with like no updates. So you'd better like migrate to this new Intel LLVM. And there is migration guide with the details published. So like, again, you won't be alone there. So there is some help. But yeah, it's actually an interesting move. I mean, like many IDEs are now moving to Clang and especially to ClangD as a daemon. And it's nice to see compilers moving to LLVM. I wouldn't be like, I think that was the thing mentioned also at CPPcast, if I'm not mistaken. But again, like, I wouldn't be surprised if the Microsoft will also move there. We'll see. Who knows? It's definitely tougher for them because they have the whole ecosystem of the Visual Studio also using this compiler infrastructure for parsing the code, for doing all the stuff. So it's definitely not that easy. But it's an interesting move. I mean, LLVM is it's not just a Clang compiler. It's much more now. Like, we have this Intel LLVM. So yeah, in that sense, it's big news, and I would say good news. So what do you think?
So you mentioned CPPcast brought it up as well, and I know they were a bit concerned about losing another kind of major compiler implementation. Although obviously it's not the entire compiler. The LLVM is a fairly low-level component of it. And yeah, I do partially share that concern. It is good to have multiple implementations. On the other hand, but the key strength of LLVM is its modularity. So it's not just open as in open source, but it's open in terms of its architecture. It's designed specifically to be used with all sorts of front ends and for all sorts of different purposes. And yeah, this is yet another client of that, really. And in doing so, that can only really improve LLVM for everyone. Because even if they're not going to upstream all of their changes, they've got to keep some of their proprietary stuff. They're going to still be improving some of it, particularly in the area of heterogeneous computing, which is one of their strengths. So I see it as a net positive, even if there are some downsides to it as well. I think this is, a good direction overall.
Yeah, agree.
So let's focus on CLion 2021.3.
Yeah, so we talked about CLion release in July, and since that we published a blog post talking about our roadmap for 2021.3. So the release coming somewhere in the end of November, beginning of December. So by the end of the year, it should be there. So, and like, our major focus is still unchanged. So it's performance and eliminating freezes, and we do a whole bunch of work in that direction. But there are a few interesting steps we're going to take to specifically simplify the initial and overall configuration of the IDE. So the first thing is that we plan to bundle the MinGW toolchain in CLion installer for Windows, so that those who actually start with CLion on Windows can do something just out of the box, even like if they don't have anything else installed. So, and then they don't have to, go and manually install. And MinGW package is actually not that easy one. So you need to install like the CMake, the Make, the GCC, and the all these compilers. So you will spend some time going through all these packages and ticking the proper boxes. Yep. So hopefully we can help. And the next thing would be the ability to configure the toolchain environment via script. I guess a highly requested things from us. It's quite useful if you use this script to initialize all the compiler environmental variables, including the additions of the bin and lib paths. So it might really help, and hopefully we'll be able to bring this into the upcoming release. We're also trying right now to bundle Ninja and make it a default generator. So right now we're relying on the makefile generator as a default one. So, and I guess the Ninja is more like a standard one right now in the community for CMake generator. And yeah, the final thing I would like to mention here is for embedded audience. So those who are doing the embedded development, we finally plan to actually finalize and release our ongoing work on custom compiler, which means that CLion for now actually supports a pre-selected set of compilers like GCC, Clang, or MSVC, or IR compiler. But there is a work we're doing for some time already when we try to bring some format, it will be something like YAML format, where you can actually describe the things CLion needs from the compiler and just put this file to CLion and say, hey, this is my compiler. So, and the CLion will just work with this custom compiler using this information. So you just provide, the compiler features, the header search paths, the defines, and then CLion will just use them. And this is called the custom compiler support. So we're working on that for a while already. So trying to bring some reasonable format and to, so that you can actually collect and bring all this information to CLion. We're also trying to build some examples because we do realize that it's not that simple probably to build this file because it includes many pieces of information. So we do our best to provide some examples, at least for known and reasonable compilers that we know that people will be using in that way. So there are more things in the roadmap, like some pain points in the debugger we plan to address, like the long stl types and show as array mode for pointers and some others. So you can actually check out the full plan in the blog post. I just mentioned a few most interesting. So yeah, I don't know, Phil, are you expecting something interesting from us?
I'm actually just enjoying being able to watch from the outside this time around. It's a different perspective. So yeah, I'm just watching it as it comes out. I don't have anything in particular I'm looking for at the moment. So
yeah, but you know where the tracker is.
Yes, I do.
Yeah, so you can put anything in. Yeah, and maybe to wrap up for today, for our and finally section, I actually have also JetBrains Think today because, we just found out that exactly 10 years ago, we started officially the C++ support in our tools. And it was not the CLion. CLion is much younger. It was an app code. And we actually first announced it in August 10 years ago. And I found this blog post. I was actually preparing for some internal gathering we had in the team, some online gathering for the team, just to help everyone to to learn what's going on in the project. And I was since we have quite many new people who arrived who actually joined the team and who probably don't know how the whole story started, I was digging into how everything started, and I found this blog post written by our current CEO, Max Shafirov, and he was working in the AppCode project at the time. And it was this nice post there saying about the C++ support in AppCode. And it was not planned, actually. That's the most funniest thing, that we actually started doing AppCode. If you don't know, it's an IDE for iOS and Mac development. So it at that time, it mostly supported the Objective-C and Objective-C++, so Swift was not there at the time. And when we started doing the Objective-C and Objective-C++, we realized that we need a support for macros in Objective-C++, and then we need the stl support and some more and some more. So we added the CPB, C++ completion, and some support for C++11 features, and like implement and override for C++ code. And only when we actually introduced the Google test support in some version, I don't remember exactly, but it was something like 1.6 or something like that version of AppCode, we actually realized that we are working on a C++ support, and we became quite serious about that. Became serious, but after that, we wrote a nice blog post for the April Fool Day talking about the C++ IDE. And mostly all the comments under this blog post were about how excited the people were about the C++ IDE. So we realized that that's no longer a joke. We have to do that. And so that's how the whole idea actually of CLion started. So, and yeah, that blog post, I really like that. And when I found it, I was nicely surprised that it's exactly the 10 years. So for C++ support in our tools. Yeah. And I was just posting a few tweets this month with this thing to celebrate exactly on August 25. But I was also posting some, nice memories from the project, like the first CLion demo, which was done in September 2013. It was called CPP ID at the time, and it was done in Malmö at JetBrains event day there. And it was quite basic things which were shown there, mostly coming from this app code implementation. And I also shared a nice tweet with the names were actually considered for CLion. And there are a whole bunch of, quite weird names. I would say that for me as a C++ developer, they're quite fine, like the Void Star or the Hackspeak. They're okay. Or like C-Trait, which is definitely okay for me. But I realized that maybe it's not for everyone. Some of them are really weird. And I'm happy we came up with the CLion name, not the Hackspeak. I don't know if you have any comments on that.
I did have a look at that video, actually, that's linked from the tweet that I'll put in the show notes. And yeah, it's a video of the screen, so it's difficult to see.
Yeah.
But it's just, just strike me just how different that initial version of the IDE looked to what we have today. And I did have a license for the very first version of AppCode. I bought that out of my own money at the time when I was doing iOS development. Yeah, it's come a long way. So.
Yeah, that's true.
Nice
that's
to look
true. back. Yeah.
Okay, well, I think we should wrap up there. But before we do go, I just want to mention one thing, which is that a couple of times now we have slipped on our monthly schedule sort of to the beginning of the following month. And part of the reason for that is because we tend to collect a lot of the information that we talk about towards the end of the month, particularly on the standards schedule, which tend to have things right at the end of the month. So it is quite tight packing it in. So what we decided to do is just make that official, and we're going to record and release the future episodes at the beginning of the following month. So we don't have to say that we're late anymore. That's really the only change.
Hopefully.
Well, yes.
Yeah.
Challenge accepted. Anyway, with that, I think we'll say goodbye and see you next time.
Yeah.
Bye.
See you. Bye.